Okay.
My name is Michael Sardella, and my senior project was on the water quality at the Bow School District, especially the water at the Bow Memorial School. So I want to start off by showing a statistic from a survey I sent out that found that 74.3% of the respondents said that the water at the middle school was not satisfactory. So, and if you ask anyone that's had it before, they'll tell you how bad it tastes and how it kind of has a bad reputation. So I wanted to dedicate my senior project to trying to fix that and trying to find a solution for it. But water quality isn't a problem only locally. The EPA estimates that 30 million Americans live in areas where their water systems do not meet safety guidelines. So the clean water crisis is like a major national humanitarian issue that I hope my project can kind of address on the local scene. So my main message is that science is crucial in every tier of our society so that we can solve and understand our problems. And that can kind of be shown throughout my project where I try to solve this local issue, but the same exact processes can be used to solve more bigger issues like national issues and things. So I started my project by researching water pollution in New Hampshire, and it helped me get like a better grasp on understanding what can be polluting the water and how it gets there. And then I started with the processes of purifying the water at the middle school. So I got a bunch of middle school water, and then the first thing I did was I distilled it. So this is basically just boiling off the water and then collecting the condensated liquid water, and then it's just pure H2O. So a pro for this one is that it's easy to do at home, which is why I did it first. But a con is that it over-purifies the water. So one of the things that's important to understand about this topic is that if you purify water too much to where it's essentially just pure H2O and there's no nutrients or anything, for one, it'll taste weird to us because every single water, all the water that we drink has at least some chemicals in it that make it taste good, and that's what we're used to. And our water has chemicals like magnesium and calcium, or potassium, and those are healthy nutrients for us that we need, so having it in our water supply is actually a preferred thing over having just pure H2O. So the next process I did was deionization, and a pro for this one is that it was fairly cheaper than a reverse osmosis system, which is that thing over there. And I'm gonna start the reverse osmosis system just because it takes up a couple minutes before it gets ready, so I'm just gonna leave that running. Okay, so, but a con for this one is that it also over-purified the water. So it made the water, once again, too much of just pure H2O, so it wasn't really suitable for drinking. And the third process I did was zero water filter, which is basically just like a bird filter. And a pro for this one is that it's really easy to use at home, and I would recommend it if you wanted a home remedy for like your tap water or something. It works well for that. But a con I found surprising was that it actually also over-purifies the water. So the water, once again, was too much just pure H2O. And the way this one works is it has an activated carbon filter in it, so basically it uses a process called absorption, and it just catches all the chemicals that's not water, essentially, through the filter. And it's also not practical on a large scale, like what would have to be used for like the school. So then here's the final solution that I found. So reverse osmosis is that thing right there, and it had the best taste results. And it's the most likely to be used on a large scale since you can just like put it in an actual water system. So the only con though is that it can be kind of expensive to install. From my research, it it was kind of hard to get like a precise number because there's so many factors that are involved when you're installing a system. But it looked like it was anywhere from like $1,000 to like $15,000 to install. So that's just something to consider. And then here are the results from all the experiments I did with the water. So I want to point out the control, which is just the raw middle school water, having 0.5 parts per million of chlorine and then 40 parts per million of alkalinity. This is, so chlorine and alkalinity is basically just chlorine and alkali metals like sodium and potassium, which are commonly known as salts when they're combined. So the water may be getting contaminated from road salt, which I'll get into in a couple slides. And then it also has a good amount of hardness, which is just calcium or magnesium in the water. And I want to point out the far right column, which is just the total dissolved solids, which just means everything in the water that's not water in parts per million is right there. And pure middle school water, it has like a lot of stuff in it. But the other three solutions that weren't reverse osmosis are clearly, they essentially are just pure water. And the range you want for the best tasting water and the most useful water is like 50 to 250 parts per million. And the reverse osmosis water came right in between that. So another thing that's really important for me to mention, and kind of a big topic that made me want to do this project, was that there's a misunderstanding with what's in the water and why it doesn't taste good, and if that means it's dangerous. And throughout my project, every test I did, there was no dangerous chemicals, and every chemical in the water was not present enough. There wasn't abundant enough to be actually a problem. It just made the water taste bad. It's not unsafe though. So the CDC recommends up to 4 parts per million of chlorine. And in the last slide, they just said that there's 0.5 parts per million, which is like way less. So I just want to point that out. And here's the results from the taste test, which just shows the reverse osmosis water had the best results. And the deionized water and the zero water filter water were very close, but like I said earlier, they're kind of too pure. It might taste weird to other people, and it might not, it's not going to carry helpful nutrients to your body. So like I mentioned earlier, the middle school water, I have a problem with salt getting into it, which can basically happen when we salt the roads, and then the road runoff gets into the groundwater, and it can cause the water to have too much chlorines and alkalinity, which will make it taste bad potentially. So that's one of the reasons that I could be doing that. So for my final thoughts, the BMS water is safe, but there are ways to fix the issues with the taste. The best solution that I found to be was reverse osmosis. And my main message really is that it's important that our community understands the safety of our public water supplies. And I hope my project can use science to assist in this goal. And I hope it can kind of demonstrate how you can use this process for any problem at any scale. So even like nationally or internationally, you can still use similar processes of science and experimentation to find solutions to your problems and understand them. So before I end it, I'm just going to do like a quick demonstration, I guess. So this is a total dissolved solids reader. So it basically tells me, that's how I got the numbers of how much total dissolved solids are in the water. So the unpurified middle school water says it has 841 parts per million of total dissolved solids. And then if I take the middle school water, or sorry, this is the purified water, the good water. Just gonna let it flow up for a second. Okay, that should be good. This is reading, turn it off real quick. Okay, so the purified water at the end 70 parts per million, so it's a drastic reduction. It's almost 10 times less of dissolved solids in it, and it tastes better than the unpurified water. So, thanks. Any questions? Yeah.
Did you build that?
I mean, I like put it in this thing. Yeah, I kind of built it, yeah. It obviously came with all the parts, but, any other questions? Oh, yeah.
So you said earlier you can over purify water. Does that, when people taste purified water, either distilled or something like that, do they think it tastes funny or what?
Well, from what I found, I can try to pull it up again. Yeah, so like I said earlier, the distilled water is just pure H2O. It basically had like nothing else. And the taste test said that I basically had like 3 people try it and I averaged the score. So I could have done a broader search, but they found that the distilled water did taste like it was kind of average, and then the reverse osmosis water tasted the best to them. But I'd say generally, I think it would taste weird to people because it's something we're not used to, and like if you go to the store and buy distilled water and try it, it's gonna like not taste as normal. But it doesn't taste bad, I guess, necessarily. So, anyone else? Okay, that's it.
Nice job, Michael.